Good day, welcome to EMILAC online tutorial, and today in the series of uniformly accelerated motions, the problems in them. Now here's the first question. Now starting from rest, a Formula 1 car accelerates uniformly at 25 centimeters square for 30 seconds. What distance does it cover in question number 1, last 1 second of motion? And question number 2, the 17 second of motion. Now first of all, you need to understand that this last 1 second of motion doesn't mean 1 second as per the time, but it tells you the interval between the 39th and 30th of 30th seconds of the motion, which means the interval between 29th and 30th second of motion, of the motion. All right, so with this now, we'll need to write out the parameters that is involved in this. Here we are given that the acceleration A is given as 25 meter per second square, and time is given as 30 seconds, and we are asked to find the distance. Okay, and since the car in question is starting from rest, then automatically u equals to 0. Yes, now from here now, from the last video I did to the introduction, I made mention of the 4 different equations of motion. You can watch that video to get to know those equations. Now, but one of the equations is what we're going to be using here. Now, since here we have the acceleration, the time, the distance, and the initial velocity, so we can make use of s equals to ut plus at squared over 2. Okay, now with this equation now, but take note here, the distance here is between the 29th and the 30th second. Okay, so here we can say here that our distance here will now be the distance between the 30th second minus the distance at the 29th second. Okay, so let me move further. So the distance here will be that s equals to u, then our t 30 minus t 29, then plus a into t square for 29, no sorry, for 30 minus t square 29 all over 2. All right, so we will now be implementing every of our parameters into them. Now, but since our u here is 0, automatically this is now ruled out now, because this equals to 0, and 0 times whatever we have here is 0. So our s now, which is the distance, we now have that this is a into 30 square minus 29 square all over 2. Take note, our a here is supposed to be 25 according to the question here. So here we have this 30 square minus 29 square, then over 2. So as such that s here equals to, so here we have 25 now into 30 square will give us 900, then minus 29 square should give us 814 all over 2. So, and this try to give us this 2 here, 1, 2 here, 1, 2 in 5, 2, remainder 1, in 1 impossible, then in 10 we have what, 5. So here 900 minus 841 should give us 59 59. Yes, 59. And when you multiply these together, we're using calculator, we have a 737.50 meter. All right, so now we've answered the first question, so let's move on now to the next question. Now for the next question, we are told to find the 7th second of the motion. Now this is the time interval between the 16th and the 17th seconds. Now you're still using the same equation, ut plus at squared over 2. So in this case also, this, because our initial velocity u is 0, so 0 times t here should give us 0. So working with this, we have that 25, then into bracket the 17th square minus 16 square all over 25. The same thing also, this should give us 12.5. So this should give us 12.5. Then open bracket, 17 square should give us 289. Then minus 16 square should give us 256. Okay, so our distance here will probably give us 12.5. Then into bracket 289 minus 256 should give us 33. Now 12.5 times 33, using our calculator, we should have 142.5 meter. All right, now this gives the solution to this problem on the board. All right, you can see it's very simple, it's concise. All right, like my video, share my video, and if you are coming to this YouTube for the first time, thank you and God bless you.